All right, so this is on paper 3. There's always a few questions that are sort of data-based questions at the beginning of paper 3 that are kind of overall. And this is one of them. And they usually deal with uncertainty or drawing graphs or something like that. So a student uses an electronic timer in an attempt to estimate the acceleration of free fall of g. She measures the time taken for a small metal ball to fall through a height of h, presumably from rest, right? So here's this, ball, and we time how long it takes to fall, 0.5 meters, right? And then we're going to calculate g, right? So if the height is 1/2 gt squared, then h is going to equal, what is it? It's going to be, oops, no, we don't want h. G is going to equal, what is it? It's 2h over t squared, right? So g is going to be a function of h and t times t, right? So remember, with uncertainties, you can just simply add up the uncertainties, right? And so you're going to add up the height once, so there'd be 0.6. Remember that you do that with percent, right? The percent uncertainty, right? If area is length times width, right? And this is, say, 2%, and this is like 7%, then your area is going to be 9%, right? You can do that with percents because you can add the fractional uncertainties, right? So in this thing, what you're going to do is you're going to have one of these 0.6s because you have 1h, right? But you have two factors of t because t squared is t times t. So it's going to be this plus this plus this, right? And you'll end up with something, okay? Now notice that these uncertainties are only 1 sig fig, so I arrived at an answer that had 2 sig figs, but it's okay, it's all good. All right, and then it says state and explain how the student could obtain a more reliable value for g. In this case, the marks team gets, this is a sufficiently vague answer, and it's 3 marks, so it's kind of a worst case scenario. Hopefully they'll never ask something like this, right? But one of them would be that we use a bunch of heights, right? And then we do something complicated with a graph, right? And then the other way that they sort of talk about it is that they talk about the apparatus itself, right? And they talk about the ball to reduce air resistance or something like that, a more dense ball or something like that. In the mark scheme, it says like a smaller one, which if it was too small, it might actually increase the air friction. But anyway, use a larger height. That's sort of what I came up with, right? Maybe do many trials, right? Come up with things, and I don't know exactly. I mean, looking at the mark scheme, I just don't know how they're going to actually do that, right? I came up with like maybe using an accurate timer or whatever, right? So just have at it, see what you do, and see what somebody grades it as, right? Good luck, happy hunting.